Okay, in this part of the video, we're going to presentation. We're going to be looking at time-based basics. Now, many of you, this is fairly intuitive, but some of you may not truly understand the relationship between the time base on the oscilloscope and the waveforms you're actually looking at. So we're going to have a little bit of a look at that. So let's go back to our picoscope. And here we have a 1 kilohertz waveform, 1 volt peak to peak with a 0 offset. So here, as we talked earlier on about the vertical scaling, so we're going to plus 0.5 volts, minus 0.5 volts, plus 0.5, minus 0.5, and it's based around 0. But what is the actual frequency here? Well, the period of a waveform, which is the from going from 0 through a complete cycle back to 0 again, is the period of the waveform, and you calculate that by taking the frequency and taking the reciprocal of the frequency. So if you do 1 over the f, then that will give you the period. So at 1 kilohertz, we can say that that gives us a 1 millisecond period, which is the period time in here. So we've got our time base here set to 1 millisecond per division, and these are the divisions. So there's our division graticules here, and from that trigger point we can see that we've got one complete cycle in one division. That's 1 millisecond, and therefore if we take the reciprocal of 1 millisecond, we end up with 1 kilohertz, and that's the frequency of our waveform. So if I now change my waveform to 2 kilohertz, so we should see 2 cycles in that time period, because we've actually increased the frequency, shortened the period, and to the period now is, if it's 2 kilohertz, will be 0.5 milliseconds or 500 microseconds, and we should see 2 cycles in a 1 millisecond period, which is any of these periods here between these graticules. We can change the time base here to look at this in a bit more detail. So we can change this to 500 microseconds. And so here you can see that we've got 500 microseconds per division here. And that means that if we take the reciprocal of that, we've got 2 kilohertz, which is in fact the frequency of this waveform. Now then, if we now change this frequency again, and we now go really high, and we're going to change this to 1 megahertz here, and you get this wall of color. So if you're ever connecting up your system and you see this wall of color, then you've definitely got a signal there, which is brilliant. What frequency is it? If you're not too sure, then what do you do when you see this wall of color? Well, you need to be increasing your time base to try and see your signal. So you could progressively go through this. And this is why I was saying to you earlier on that if you use a scope from a place of knowledge and understand your signals, then you know that if you've got a 1 megahertz signal, the period is 1 microsecond per division, and therefore we could go straight to 1 microsecond per division and we will see our signal. And this just reinforces why having a knowledge and understanding what you're dealing with allows you to set up your scope for you to see what you need to see and want to see. Because they really can cause significant problems for people that are new to them, and students in particular when they do certain things. Because I'm about to show you something which is rather interesting. We have a 1 megahertz signal here, but what happens if I now have my scope set up at this high frequency, and I've got it set up to 1 microsecond per division, and then I decide to put, or my signal does something weird and it goes to 1 kilohertz. So I'm going to put in 1 kilohertz now. Now the problem with this is that unless you know what's going on, you will see this and go, oh, right, okay, I've got no signal now, it's a 0. You have got a signal, it's just your time base is wrong. And so students could be playing around with scopes and trying to find out what's going on. Now you could go into auto mode and find out what's going on. But the problem with auto mode is you're continually changing what you expect to see in terms of settings. And so it's always best to know what you're dealing with and looking at, okay? So in this case, you just see the signal, and as far as you're concerned, there's no signal there. But there is. It's just the time base is wrong. So this is possibly one of the reasons why the default is 1 millisecond per division. Because if you go to 1 millisecond per division, then you see a relatively slow waveform. So that if I go back to 1 megahertz again, like this, if you get this wall of signal, then you know you've got signal there. And okay, your time base is incorrect, but it's better to have a lower time base like this in the 1 millisecond, 10 millisecond range, so that you can actually then go, right, okay, there's a signal there. I wonder what it is. And if you're not too sure, then just keep on changing the time base like this until you get the signal you want. And so this is really just trying to reinforce this thing about understanding what it is that you're dealing with. But if you're in doubt, then always slow down your time base so that you're always in a position of knowing there is something there, rather than having a very high time base and not realizing there's a signal there at all. Okay.